So far, we learned how to use PGP to encrypt messages so that only the receiver can read the content of the message. To do that, the sender, David in our example, uses the public key of the receiver. So the receiver makes their public key public, as the name suggests. That's fine because the public key cannot be used to decrypt messages. It can only be used to encrypt messages. So David encrypts the message with the receiver's, John's, public key. The message is sent, and when John receives it, he uses his own private key that he never shares with anybody to decrypt the message. Therefore, David can send the message to John in any way he wants. He can send it as a text message, as an instant message, or even using an insecure service. That's fine because if anybody reads the message, they will see gibberish. They won't be able to see the content unless they have the private key. And as long as John doesn't share the private key, there's no need for him to share it, then nobody will be able to read this message except for John. So that's really, really good. The only problem here is that there is no way for John to verify that the message that they received has actually been sent from David. So like I said, for this to work, John needs to make their public key public. So getting the public key of John is easy. Therefore, John could have it in his signature in his email. He can have it in his signature in a forum. He might have it publicly shared because he wants people to send him encrypted messages. So there is nothing wrong with making your public key public. The only problem is someone can come in, pretend to be David, use John's public key to encrypt a message and send it to John. And that way, John has no way of knowing whether this message did actually come from David or not. To solve this problem, David will have to sign the message. This can actually be done with PGP. So let me show you how this will work with this example. So again, we have David. He wants to send a secret message to John, and as we learned before, the first thing that David will do, he will use John's public key in order to encrypt the message. The message will change into gibberish. Now, at this stage in the previous lecture, we sent the message, but this time, David is going to sign the message with his own private key. So he still hasn't sent the private key. The message is still at David's end. And what he's going to do is he's going to create a signature for this message. This signature corresponds to this message, and if anything gets modified within the message, if one letter gets modified, the signature will change. Therefore, this signature can be used to verify that the message has not been modified since it got signed by David's private key. Now keep in mind, David is still keeping his own private key. He did not send it through any method of communication. So now we have a message with an encrypted content and with a signature that corresponds to David's private key. Then the message is sent using any method of communication. Like we said, you can even use an insecure method of communication. John is going to receive the message along with its signature. And before decrypting this message with his own private key, what he's going to do is he's going to use David's public key in order to verify the signature. So like I said, the signature was created with David's private key, and then John doesn't have David's private key, but he's going to use David's public key to verify the signature. If the message was not modified, the verification will be successful, and this way John will know that this message was actually sent by David and was not modified by anybody, because like I said, if one letter gets modified, the public key, David's public key, will not verify the signature. So when the signature is verified, we know that David was the actual sender of the message and the message was not modified as it was sent, whether it was sent over the internet as a text message or using any other method of communication. The next step is very similar to what happened in the previous lecture. John will use his own private key in order to decrypt the message and read its content, which is just secret message. So as you can see, as a result of this, each party still kept their own private key. Nobody sent their private key to the other party. So the sender encrypts the message with the receiver's public key and signs the message with his own private key. The message is sent, the receiver verifies the signature with the sender's public key and decrypts it with his own private key. This way, he can verify that this message came from the sender, he can verify that the message did not get modified as it was sent, and the message is encrypted, and the only person that can read it is the receiver because he kept his own private key private and it was not shared with anybody. Right here I have John's computer, and let's go ahead and send a message to David. So as we've seen before, the first thing you want to do is open up a text editor. And we're going to type the content of our message. So I'm just going to say this is a secret signed message from John to David. Now, like we've seen before, I'm going to select all of this. I'm going to copy it. I'm going to go to my PGP clipboard and I'm going to click on Sign Encrypt Clipboard with Public Keys. Next, we want to select the public keys that we want to encrypt the message with. And like I said, I'm sending this message to David, so I'm going to tick him. You can also tick John if you want to be able to decrypt your own message. And unlike what we did in the previous lecture, before clicking on OK, I'm going to go to Sign Message As. If you click on this list, you will see a list of all of the private keys that you have on this computer. So this is John's computer. And as you can see, the only private key that we have is John Wick's. So I'm going to select that and I'm going to click OK. It's showing a warning about the key. It's my own key, so I trust it. So I'm going to click yes. And then it's going to ask you to enter the passphrase that you selected when you created this key. I'm going to hit OK. And as you can see right here, the icon of the clipboard changed to a lock, which means that now in my clipboard, I have the encrypted message along with the signature. So I know in my diagrams in here, when we were sending the message, I said we're going to send a message with its signature, but in reality, both the message content and the signature is all going to be one block of text. So if I'm back here at my text editor and just paste whatever that is in my clipboard, you'll see we'll just get one block of text that contains the content of the message and the signature. So as we did before, I'm going to go to my email. I'm going to compose a new message and I'm sending this to David Smith. And I'm going to paste the message along with its signature, like I said, and I'm going to click on Send to send the message. Now, let's go to David's computer, refresh our inbox, and click on the new email. We have the message contents. So again, we're going to select all of it, right-click, copy, and as you can see right here, we can see the lock on the PGP applet. One click on this and we're going to click on Decrypt Verify Clipboard. So the steps are very similar to what we did in the previous lecture. Now it's going to ask me to enter the passphrase for my own key, for David Smith's key. And as you can see, we see the content of the message. Again, very similar to what we've seen in the previous lecture. But at the same time, you can see at the bottom in here, it's telling us that this message has been signed with a good signature of John Wick. We can also see the key ID and the key fingerprint. So right now, we're sure that the person that encrypted this message, the sender, is actually John Wick, and it's not someone else that is pretending to be John Wick. Not only that, but we're also sure that the contents of this message was not modified as it was transmitted to us. Because like I said, when data is sent over the internet or over a lot of methods of communications, it passes through a number of hubs, and each one of these hubs could be modified. Not only that, it can also be intercepted by a number of methods, and when hackers or agencies intercept them, they can modify them, implant data, or remove some data. Therefore, when the signature checks out, as we can see in here, if it's verified, that means that the message was not modified since it was signed by John's private key. Now you can also see that there is a warning saying the key is not certified with a trusted signature. This is fine, you can actually ignore the message. It's just because the key is not set to be trusted. But what's really important in here is to see if this is a good signature, because like I said, if it says it's a good signature, that means that the message was signed by John's private key and it did not get modified since it got signed by his key. So right now we have a method to send data in a way so that even if it gets intercepted by any party, they won't be able to read it. The only person that will be able to read it is the receiver. Not only that, but the receiver will be able to verify that this was sent from the person that they want the message from, so they can verify the sender and verify that the message did not get modified as it was being sent. Okay, so far we learned how to use PGP to encrypt text and send it in a way so that the receiver is the only person that's able to read the content of the text. Not only that, but we also learned how to sign the message, to sign the text, so that the receiver can verify that this message was actually sent from us, from the sender. So it's really good, because now when a message is sent, we're sure that it can only be read by the receiver, and the receiver can be sure that it was actually sent from the sender, and he can also verify that the message did not get modified as it was sent. So this is really good. The only problem is we can only do this for text. So what if you wanted to send a document or an image? Therefore, in this lecture, I'm going to show you how to encrypt, sign, verify, and decrypt files. So, right here, I'm in John's computer. I have the image that we already worked on and removed its metadata before. If you don't remember how to do that, please go back to that lecture. And if I double click the image right now, as you can see, the image works. It shows us a picture of a car. Now, let's assume we want to send this message to David. And we want to send it securely so that if anybody intercepts this message or if anybody manages to read it, they won't be able to see the content of it. They won't be able to see the image. To do that, we're going to right click it and we're going to click on Encrypt. Now you'll get a message that is very similar to what we used to get when we encrypt text. You need to select the public keys of the people that will be able to see the contents of this file. In my case, I'm sending this to David, so I'm going to take David from here. And as we learned before, you can also sign the message from here and select your own private key. And that way, when the receiver receives the image, they can verify that the message or the image was sent from you by verifying it with your own public key. So I'm going to click on OK. This will ask me for my passphrase for my private key because I selected the sign option. If you did not select the sign option, you will not see this. And once I put the password, as you can see, I will have a new image created. And this image doesn't really display, it doesn't really work. So if I double click it, you actually won't see anything in here. And the reason for that is because this image right now is encrypted and the only person that can see it is David. So we need David's private key in order to see the contents of this message. Therefore, like I said, right now we're in John's computer. So even John can't see the content of the image anymore. And what we're going to do is we're going to go ahead and send this as an attachment in an email to davidsmith@ilu.in. I'm going to scroll down. I'm going to select the image. And keep in mind, you want to make sure you select the encrypted image, not the normal image. So right here, we have the normal decrypted image. As you can see, we can see it in here in the preview. And right here, we have the encrypted version of it that will not work unless we have the private key of David. So I'm going to click on open and just say test in here in the content and click on send. Perfect. Now the message should be sent. So let's go to David's computer. We'll refresh the inbox. We have a new message. Perfect. Let's go ahead and open it. And we're going to download the attachment. Save it. It's going to go in my Tor browser directory. That's fine. Click on save. And let's go ahead and open the containing folder. And as you can see, we can't really see the contents of the image. Now, this is the same whether this was a PDF or a Word document or any file really. I'm just using the image as an example. Now, in order to decrypt this message, because this is David's computer and because this message was specifically encrypted for David using David's public key, we can actually decrypt it right here because we have David's private key and we'll be able to see the contents of it. To do that, we're going to right-click the image. We're going to click on Open with Decrypt file. This will ask you for the passphrase for David's private key. I'm going to input it. And perfect. As you can see, this will create a new file. This is the image after decryption. And as you can see in the middle, it said that the signature has been verified. So we're sure that this image was actually sent from John. Now I can double click the image to see its content. And as you can see, I'm able to see the contents of the message. So the idea behind this is very similar to the idea of sending text. We encrypt the message with the receiver's public key. If anybody manages to get their hands on this file, whether it's an image, a PDF, a document, doesn't really matter, they won't be able to read the content of the file unless they have the private key. Now, there is also one more feature that I want to cover in this lecture, which we can use to sign the file without encrypting it. So if you remember, when we downloaded the Tor browser, we also downloaded a signature and we used that signature to verify that the Tor browser did not get modified as we downloaded it. So you can also do this to any file you send by generating a separate signature. So again, you can do this to any file you want, whether it's software, whether it's an image, a PDF, a Microsoft document, it really doesn't matter. I'm using the image here as an example. I'm at John Wick's computer right now, and all you have to do is click the file that you want to sign, click on sign. It'll ask you which private key you want to use to sign this file. Like I said, I'm in John Wick's computer. The only private key that I have right now on this computer is John Wick. So the only entry I have in here is John Wick. So I'm going to click on OK. And as you can see, this will generate a new file with a .sig extension. This is a signature that corresponds to this file that has been generated using John Wick's private key. So people can use this file to make sure that the image did not get modified since this signature file was created by John Wick. And to do this verification, they'll use John Wick's public key. So the private key is used to generate the signature. The public key gets used to verify that the signature did not get modified. Now, if you're doing this, you will obviously have to send the signature file with the image file to the receiver. So let me do this really quick here. Again, we're sending this to David Smith. And like I said, you want to make sure you first select the file that you want to send, which in my case is the image, and you also need to select the signature. So I'm going to select the image first, and then click on attach. And then I'm going to select the signature file as well, like I said, and we're going to open and click on attach again. And right now we have the two files added to the message. I'm going to click on send to send the message. Now keep in mind, right now we did not encrypt the image. If someone manages to intercept this file, they'll be able to see the contents of the image. We only signed the image with a separate signature so the receiver can verify that the image did not get modified as we sent it. So go into the receiver's computer. Let's go refresh the inbox and we'll go open it. Open the new message. And let me actually delete what I have in here for now. And we're gonna download the image. And then we'll download the signature. And go into the downloads directory. As you can see straight away, we're able to see the contents of the image. So the image was not encrypted because all we did is we generated a signature for the image. So the whole purpose of this is to allow the receiver to verify that this message was sent by John and that the message did not get modified since John created this signature. To do this, you right-click the signature, and we're going to click on Open with Verify Signature. And as you can see, it's telling us that this is a valid signature. And like I said, the untrusted warning can be ignored. It literally just means that the key has not been set to trusted. But the fact that it is saying a valid signature means that this image did not get modified since John created this signature right here using his own private key. So that's it for this lecture. In the previous lectures, we used email to send the keys from one person to another. Now you can use any method of communication. And like I said, sometimes if you're using a market or if you're on a forum, you might even see the user including their public key in their signature or in their profile page. That way, you can use that key to encrypt messages and send them to that user, and you'll be sure that the only person that will be able to read this message is the user. Now, there is another way of sharing the keys, which I want to cover in this lecture, and that way relies on using key servers. So you can think of this as a computer that's accessible on the internet or on the darknet. It contains a number of keys. And then, for example, if David wanted to share his public key with John or with anyone else, they can upload their key to the server. Same goes for John. If he wanted to share his public key with others, he can upload his key to the server as well. And then, if David wanted to communicate with John, he won't need to ask John for the public key directly, and John won't need to communicate with David directly and send him the key. All David has to do is query this server, the key server that is accessible, like I said, on the darknet or on the internet, and download John's public key. Same goes for John. If he wanted to get David's public key, he can query the server, download David's key, and that way both David and John have each other's public keys, and therefore they can start communicating and encrypting messages to each other using each other's public keys. The only thing that you want to keep in mind when doing this is when you upload your key to this public server, anybody can get your public key. Now, like I said, the public key cannot be used to decrypt your messages, but as we've seen before, there is an identity tied up to the key. Now, we used fake information, but if you're using real information, the name will be visible on that key, and the email associated with that key, again, like we've seen before, when we create a key, we set an email address with that key, so that email will also be publicly available. So if you don't want to make this information available, then do not upload your keys to these key servers. Also, if the key is associated with other keys or part of a chain of trust, these keys will also become available along with the information tied up to them. So any contacts associated with the key will also become available and public once you upload that key to the key server. So again, if you don't want this information to be public, then do not upload your key to the key server and just send it directly to the people that you want to share your public key with. But like I said, the main idea remains sound. Sharing the public key does not compromise the encryption. The public key cannot be used to decrypt the messages. It can only be used to encrypt them. Hence the name public, and that's why we can actually share it with anyone we want, and we can just make it publicly available. Now, let's see how we can do this. So first of all, I'm going to go to John's computer right here. And let's say that I want to make my private key, so this key right here, available, and I want to upload it to a key server. Now, before uploading it to a key server, I need to enable this feature. And to do that, we're going to go to Edit, Preferences. And in here, when it says Publish Keys to, I'm going to click on the drop-down menu and select this server right here. Now, as you can see, this is an Onion service. Therefore, whoever is going to download this key needs to be connected to the Tor network. Now, I'm going to close this. And the next thing that I'm going to do is upload this key to the keys server. So to do that, we're going to go to Remote and Sync and Publish Keys. This is telling us that one key is selected and it's going to be synchronized and uploaded to the key server that we selected. We're going to click on Sync, and this will upload my key to the key server that we selected. Now, anyone who wants to communicate with me, with John Wick, they can query this key server and find my public key and use that to encrypt messages for me. So in our example, it's David that wants to communicate with John. We have his computer right here. And all he needs to do is open his passwords and keys from the utilities as we've seen before. And he's going to first select the GNU PG keys, go to Remote, and click on Find Remote Keys. So these are the steps that you need to use if you want to pull a key from a key server. When you click on this, you'll get a search box, as you can see in here, which you can use to search for your contact. You can search using the name associated with the key, as we know that's John Wick. You can also use the email or the ID. I'm just going to use the email, which is jnck7@elude.in. And I'm going to click on Search. Now, as you can see, I have the result right here. Now you can right click and look up the properties of this contact. And you can see this is for a person named John Wick. You can see the email, you can see the key ID, and if we click on details, you'll also be able to see the key fingerprint. Now, ideally, you'd want to confirm the key ID and the fingerprint with your contact before adding this key, because as we've seen, anyone can publish a key to the key server and claim to be anybody. So we're not sure that this John Wick is actually the John Wick that we need to communicate with. Therefore, you should communicate with your contact using another method of communication, for example, by email, by phone, or by text message, and confirm the fingerprint and the ID that you're about to add to make sure that this is the correct fingerprint and the correct ID for the key that you want to add. Now, obviously, John can get this information again by going to his passwords and keys, right-click his own key, click on properties, and he can get his own fingerprint and use that to help you confirm that this is the right contact. Once you're sure this is the right contact, you can click it in here and click on import to add it to your keys. And as you can see, it got added in here into my keyring. And then, as we've seen before, you can start typing messages and encrypt them from the applet in here, or encrypt files by right-clicking the files and encrypting them. So basically, I just wanted to show you another method of key exchange, how you can upload a key to a key server and how your contact can download it, or how you can download a key from the key server. Now keep in mind, when you upload a key to the key server, it might not become immediately available. I actually paused the video and resumed recording after several hours after uploading the John Wick key, because usually there are more than just one key server. So when you upload your key to one of these servers, it actually takes some time for the key to be shared with all of the servers and to become available for everybody to download. So if you uploaded a key and your contact tried to download it within the same hour and couldn't find it, then that's fine. Just tell them to wait for a few hours and then they should be able to download it.